There are some important and notable differences between C and C++, and we're going to talk about them in the next set of videos. One interesting difference between C and C++ is that C++ functions can take default parameters. For example, let's say I have function f that takes integer x and integer y. Well, I can say that integer y has a default value of 1. And then I can call function f by only passing in one argument, and 5 would have to go to the x. And that means, since I don't pass in a value for y, that means I use the default value of y. On the other hand, I could pass in 2 values to f, and then the second value would be assigned to y. It wouldn't use the default value. This is something, this idea of default parameters gets used a lot in the C++ language, and it gets used a lot with member functions of classes. And we'll look at this more. And a pretty big difference is this idea of function overloading. In function overloading, you can have 2 functions with the same name as long as they take different parameters. They need to be different types or different numbers of arguments, because the compiler is going to have to decide based on how you call the function, right? Not just the name of the function, but what you pass to the function, which version of the function you want to use. So it has to be obvious from the parameters which function you mean. Okay, but kind of an interesting little trivial part of this is that the return alone can't distinguish overloaded functions. So you can't have 2 functions with the same name and only different return types. That's not allowed. There has to be a difference in the parameters. C++ also has a special kind of pointer called references. References are not the same as pointers. They work differently than pointers, but they give you similar functionality. So for example, I can declare x to be a reference by putting an ampersand to the left of its name when I declare it. And what this does is it makes x an alias of y. And so anytime I modify x, I'm actually modifying y. This is pretty powerful, and it's used a lot when you call functions and you want to pass a value into a function by reference. Well, you don't have to use pointers anymore. You can just use pass by reference instead. C++ offers a lot more types and objects. For example, we have a Boolean type now, which you can explicitly set a Boolean variable to true or false, and true and false are keywords in the language. And there's also a string object that will take something like a character string as an initializer. And then the compiler also has the ability to deduce what types are for you by using the auto type. You can just declare a variable as type auto and initialize it to something, and the compiler figures out what you want it to be, what type you're really meaning for it to be. A few other things I want to highlight. Input and output to the screen. In C, we use printf and scanf. But as I've said before, C++ prefers to do things with objects. And so there are things called stream objects and stream operators that we can use to perform input and output. Cout is an output stream, and these double arrows are output stream operators, and they allow us to output things to the screen. And cin is an input stream. And again, using the arrows, it would allow me to take something from the terminal and stick it in variable x. So this code here in this function f will print out, enter a number, and then read in that number into variable x. This has a certain simplicity to it over some of the quirkiness of printf and scanf that some programmers like. However, printf and scanf are still available for use. So you can use either one. And we'll talk a little bit more about these stream objects and stream operators. There's also this idea of namespaces. Namespaces allow you to group variables together into a namespace to guarantee that you have unique names in your program. You're going to see us label a lot of things as std : and that's a way of saying this variable or this function is part of a namespace. It's part of the standard namespace. And in that way, things that are part of the standard namespace don't collide with things that you name that could have the same name but not be a part of the standard namespace. Okay, and then there's a whole slew of other kinds of objects that we're going to take advantage of. And one of them, one common one, is a vector. And with vectors, you can parameterize the kind of type they take. Like you can say, I want a vector of int, and then you can stick a bunch of ints inside of it, and kind of use it like an array. And it has a member function that'll tell you its size. And you can even access it using like an array notation and say, oh, give me the second thing in my vector. And you can make vectors of floats just by changing the type here in brackets, or you can make a vector of doubles, or you can make a vector of characters, or you can even make a vector of rectangle objects. Any type you have in your C++ program, you can make a vector of those things. And this is really, a specific kind of object that exists that we're going to use. And we'll actually learn how to make objects that work in a similar way, that can be parameterized to operate on different types of types or classes. Okay, these are the highlights. These are some of the differences between C and C++. And we'll see more about these specific examples. But then as we go across the semester, you'll learn a lot more in depth about how the C++ language actually makes it possible for all of these things to be supported.